All right. So it's 5:15 in the afternoon for me and something 15 for all of you. I don't know. My name is Wendy Mackay, and I'm very happy to be the chair of the Lasting Impact Award for this year. And I wanted to say something first, that every year, this is a process, and after 10 years, we look back and we say who has had the biggest impact and you know what is important. And there's usually a big discussion and so on. And this year, we had a paper that came in that just met the 10-year deadline, and it blew everything else out of the water. It has almost 2,500 citations. If you look at Google Scholar, I just looked it up, which is way more than not only any other paper in the category of, you know, just eligible for this year, but of any UIST paper ever. And so it was really pretty easy for us to make the choice this year. So I'm going to share my screen for like 30 seconds here, if I can get this going here. And so it is my pleasure, and it's not really, yes, share screen, share, there we go. So it is my pleasure to announce that the winner of the 2021 UIST Lasting Impact Award is KinectFusion. And so yay, everybody, congratulations, wonderful. And what we will do is try to have a discussion about the paper. The idea is to look at a new version of it that has, well, I won't say a new version of it, it's an old version, but a new video that hasn't been shown as I understand it. So we'll get to see a new video that we haven't seen before, give you an idea of what it's all about. And we'll let Shahram work with his other co-authors and present that. And then after that, I have a set of questions that I will ask them, and we will also open questions to the audience to find out about what, you know, what inspired you to do this work and so on. So with no further ado, you don't really want to hear from me. What you want to do is hear from them. And so I will close this, if I can figure out how to do that. Where did it go? Turn it over to you guys, to Shahram, I think, if you're the one who's going to be sharing.
Oh, perfect. Thank you, Wendy. Thanks so much for the award. This means a lot to us, all the authors listed here. I can't believe it's been 10 years. It's flown by, and it's actually great to reconnect and see so many familiar faces and names on the video chat right now, including my co-authors, some of which I haven't seen for a long time, but also the UIST community, a community that's very dear to our hearts, a community that I've been part of for the last 10 years or so as well, and it's great to see everyone here. The award means a lot to us. So I wanted to first of all, introduce our co-authors as well. So who else is online? I see Steve, I see Dustin, Dave Molyneaux, Richard is here, Richard Newcombe, great, awesome.
Dustin as well.
Dustin as well, perfect. Do all the co-authors want to first come and quickly introduce yourselves and just say a little bit about what you've been doing since KinectFusion for the last 10 years. Maybe we can go, let's start with Richard, actually, who's one of the principal leads on the project. Richard, do you want to come off mute if you're there?
Thanks, thanks, Shahram. Thanks, everybody. Hopefully you can hear me okay. Richard Newcombe here. It was my great privilege to be an intern in Shahram's group at Microsoft Cambridge whilst I was doing my PhD with Andrew Davison at the incredible Robot Vision Lab at Imperial College. Shout out to Andy and several other awards that have happened from his lab in the last couple of weeks. And since that time, I followed up with my PhD from Andy's lab and with Murray Shanahan, who's now at DeepMind as well. Went off to America to do a postdoc with Steve Seitz and Dieter Fox in related areas of 3D reconstruction and more real-time robotics, computer vision work. Started a company with Andy, in fact, called Surreal Vision, and co-authors Renato and Steve, and sold that in 2015 to Facebook and joined Michael Abrash at Oculus Research, now Facebook Reality Labs, and built a group there where we've been essentially looking at the frontiers of augmented reality and immersive experiences, and also artificial intelligence in an always-on setting. So it's been an epic arc over that 10 years for myself, but a really fun one. And it really kicked off in that kind of 2010, 2011 period with the gang here, and couldn't have been more fortunate really to be part of what really was an incredible conflation of the right opportunity at the right time with the right tech, and we'll get into some of that for sure. But it's been a brilliant 10 years, and I'm really thankful for this recognition of the work that's seen us over this 10 years do quite a lot together and apart in similar areas of AR. So thank you, everybody, and hand back to the next person.
Richard, thank you. Shall we have Otmar go next? I'll just work through you.
Yeah, hi everyone. I think quite a few people in the audience may know me. I've been a regular at UIST for more than 10 years now. It's great to see all these faces. It's great to see the co-authors, to see people that you see at least once a year in October normally. As Richard already said, this was a fun little project, fun year, in fact. There were quite a few papers or projects out there that I remember quite fondly. And it's a great honor to receive this award, or be a small cog in the machinery of people that receives this award. And I'm looking forward to this panel discussing some of the questions that surround KinectFusion and what happened since. Shahram asked to introduce what we've done since. After a couple of years at Microsoft as a postdoc and then as researcher, as some of you may know, I went off to Switzerland and I'm now associate professor at ETH Zurich. I still enjoy pointing sensors, predominantly cameras, at people and building algorithms to try to figure out what these people are doing. So more of the same. And with that, I think I can hand over back to, I don't actually know what the author list is. Someone, Shahram, you have to manage.
I had to dig it up as well, Otmar. So we have David Kim next, but I'm not sure if David is able to join us. I think he's taking a well-earned vacation. But David, if you're there, please do shout. I think next is David Molyneaux. David?
Hey everyone, I'm Dave Molyneaux. So it's very humbling to be accepting this award as in collaboration with my co-authors here. Thank you very much for the recognition there, and very pleased to have been a small part of this project. It's had such a large impact. And I'll just give you a little overview of where I've been since that work. So basically, at the time, I was doing a postdoc in Microsoft Research in Cambridge in England. And then after that, I actually moved to Microsoft Kinect for Windows team in Redmond, and that's where we actually worked on the productization of KinectFusion, and that actually shipped in the Kinect for Windows SDK. So a lot of my career has basically been taking research into product, and that was a theme when I moved to Intel RealSense after that, which is actually then starting to look at larger scale reconstruction, and that shipped also in the RealSense SDK there. And then after that, I was on to Magic Leap, and here basically looking at large-scale reconstruction, but now on mobile compute-constrained devices, such as the Magic Leap head-mounted display. And so a lot of the work that we've done in the early KinectFusion work has sort of inspired all this work that's happened on the larger scale. And certainly, there's been a lot of authors who've worked on this larger scale issue, and eventually, actually, mobile device KinectFusion as well. And right now, I'm at Facebook Reality Labs Research, part of Richard's team, working on live maps and focusing more on object detection and tracking.
That's perfect. Thanks, Dave. Next up, so I think Pushmeet Kohli and Jamie Shotton unfortunately couldn't be here, but they send their thanks. Steve Hodges. Steve, are you there?
Yep. Yeah, I'm here. Thank you. Well, I think I'm one of the few co-authors who is still at Microsoft Research. I don't know whether that indicates, a lack of ambition or a commitment to MSR. But my work's actually, since then, my work has moved away from sort of camera-based. I've always worked in sort of sensing and more at the hardware level of things, and I moved away from camera-based work, and I've been more focused on physical computing and working in computer science education, things like the microbit Microsoft MakeCode platform. So I guess my career has gone, in some ways, has gone in a different path, because even though I've stayed at MSR, I've moved away from this field. But like the other authors, I mean, they've already said it, but it was an amazing time at MSR, I think, and we had a group of people who were, in some sense, I think in some ways, I think this is a great example of the kind of work I like to see at UIST, which is really trying to apply the latest technologies to real world applications, like thinking about what you can do with these things, building end-to-end systems. And I think with KinectFusion, perhaps we'll get onto perhaps in the panel discussion, why do we think this work had so much impact? But really what we were doing was bringing together a number of technologies. And like Richard said, it was kind of, we were in the right place at the right time with the right technologies, and combining that with some idea of what you might do with these things, how they might, really make a useful system. So again, like the others have said, I'm super proud, happy to be a co-recipient of this award, and to have played a very small part in the project.
Wonderful. Thanks, Steve. And I think you're onto a good thing staying on at MSR. I really miss it myself. Next up, we have Dustin Freeman. Dustin, do you want to jump in?
Hey, folks. This is being on this paper was definitely a right place at the right time thing. I actually was brought on to be an intern at MSR for a different research project with Otmar, which was sort of comparing a Wiimote style interaction with a Kinect style interaction. What's the feeling of having a physical object in your hand, and how does that change user behavior? And then I got sucked into this project to build a bunch of demos, which is interesting. So this was right near the beginning of my PhD, and then I proceeded to do my PhD on CV-based gestures that are always on in really noisy situations, mostly for immersive theater. And I did a whole side project on how do you prevent false positives in CV gestural interaction. And then that only worked so well. So I put that aside for a while, worked for a series of startups in the Bay Area. And then in the summer of 2019, saw a demo at a company called Control Labs with a neuromotor-based, as in muscle neural interaction gesture detection system. And it actually worked. It worked really well. It was super robust. Joined that company, and then 6 weeks later, they were acquired by FRL. So Richard and I are technically very distant colleagues right now, and so is Benko as well. And it's a very similar process. Instead of building demos and prototypes and real systems on top of CV technology, I'm doing the same sort of thing on top of neuroscience. And it was kind of a joy to be part of this paper and watch it turn something that only worked offline slowly into a real-time system. And I feel like I'm doing a really similar thing now.
That's great, Dustin. That's quite the journey. And you're based in East Coast, or
I'm in New York right now.
Awesome. Okay, and last two authors, last but not least, Andrew Davison.
Hi. Yeah, so I was Richard's PhD supervisor at Imperial College at the time of his internship at Microsoft, and was also invited to be part of the project, which was great and exciting. So since that time, I have remained in academia at Imperial. So I still run a research group focused on SLAM, real-time scene understanding, and especially applications to robotics. And I'm currently working a lot with Dyson on applications in home robotics. So yeah, thanks very much from me as well for this amazing recognition.
Thanks, Andy. Thank you. Next up, Andrew Fitzgibbon. Andrew, it's been a while. Great to see you.
Hi, everybody. Great to see you all. This was an amazing turning point for me. I spent 10 years doing two things, complaining about the algorithm ICP and building slow batch systems that solved computer vision problems. And getting involved in this project just taught me the importance of, something real time with a demo that shows all the applications you might think of. And, if you remember the KinectFusion video, it's just full of the things you can do if you do this. And also, as Andy Davison would have told me 10 years before, but I didn't really believe or understand, if you're doing it in real time, everything is different. The user is involved in correcting the algorithm. You don't have to trust computer vision to do everything. And that, really stayed with me forever. Since then, I went back to doing batch computer vision, measuring the shape of dolphins, which then turned into hand tracking for the Microsoft HoloLens. And about 3 years ago, I decided to fulfill my lifelong goal and turn myself into a programming languages researcher. So if you want to read about hashing syntax trees without worrying about the names of the variables, then you can look at, the top of the Google Scholar list at the moment. So yeah, it's been a fantastic time and amazing to get this award.
Thanks, Andrew. Great seeing all the co-authors. Thanks everyone for the introductions. After KinectFusion, I spent time at Microsoft Research, various follow-up projects that we did, some of which I'm sure we'll discuss as well. Worked on the next generation of the Kinect, worked on HoloLens, and then I left to do my own startup as well for a couple of years, which got acquired by Google. I'm now at Google. I'm the engineering lead for the AR VR team there right now. So everyone seems to have had quite a interesting path since KinectFusion, but we wanted to start by just actually showing you the video of KinectFusion. But rather than the sort of classic YouTube video that you can just go and Google and find, this is actually a pre-submission video. The project wasn't even called KinectFusion at the time. And so we wanted to just quickly show that video if possible. Jeff or Wendy, is it possible to show the video that we shared? Or shall I try and figure out how to
I'm not sure how to give that. We have an SV who should have that capability, but I am not.
Okay, perfect.
I think it'd be better if you share it, if you have it available.
Yes, I do have it. What's the best? Okay, let's see.
You have the screen share thing at the bottom?
Yeah, perfect. I'll just do the screen share. Perfect.
Yeah.
Hopefully that will work with audio as well. Sorry, I clearly am a newbie when it comes to Zoom.
There's a box to check somewhere to make sure you share your audio.
Let's select. Let me try that again, actually, because I didn't see the box. 1 second. Share screen. Can you see my screen?
Yep.
Yes. Can you just tell people what it is before we see it? Because it's a very cool system, but there are a number of people here who are very young, or not necessarily very young, don't necessarily know what it is. So just introduce it quickly and then let them see.
Yeah, absolutely, Wendy. And there is a voiceover, a narration here from Steve. So kind of hopefully gives you a little bit more insights. But yeah, this was a project that we did in 2010. That's when it started with Richard's internship. As mentioned, we were fortunate enough to have a band of people come together for this project, including Richard Newcombe from Andy Davison's Imperial Lab. And what you're seeing here is you know, at that time, the Kinect hadn't even been launched as part of the Xbox. And we had a project which was looking at trying to reconstruct your entire environment, your entire living room, and bring that into your sort of computing experience, either via, you know, augmented reality displays or even projection mapping. And so, so that was a project we actually codenamed it Holodeck. And as part of that, we started to experiment with different ways of doing room scanning. And one of the ideas we had during Richard's internship was the idea of, rather than having the Kinect camera placed above your TV screen, where it's doing body tracking for gaming, to pick up the Kinect camera, move it around, take images from the Kinect camera, in particular the depth maps that you get, the 3D information you get, and start to fuse those into a real-time model that's continuously evolving. And this is what you're going to see here in this video. A little bit more context on this video. This is not called KinectFusion because it's actually the submission that we did prior to the final video. As you can see, it's called In-Depth Reconstruction. So the name KinectFusion stuck after the paper was accepted. And there's a bit more historical data there that we can share in the panel session. But I'll just roll the video, and hopefully the voiceover and narration will explain a lot more about the system.
In this video, we show a new system which can create a dense reconstruction of objects and indoor scenes in real time. The only sensor in our system is a low-cost depth camera, which is moved around the environment to be reconstructed. As this happens, the system builds and continuously refines a dense map, whilst simultaneously tracking the 6th position of the sensor. Here, the dense model is rendered using Phong shading, and a normal map is shown alongside. A wireframe of the frustum of the mobile Kinect camera is also displayed. A relatively detailed model of an entire room can be generated quickly and easily. Here, the view from the Kinect device is shown at the top of the video, and the corresponding dense model is below. The coverage and fidelity of the model is continually being enhanced. If objects in the scene are moved, the model quickly adapts. When this box is added, the front faces appear almost immediately. Additional detail is filled in as data becomes available. A model which incorporates the detail of facial expressions and clothing is generated remarkably quickly and easily. Using data from the RGB camera, it is possible to texture map the rendered model to create a photorealistic look. Colors in the scene are refined over time as more data is collected. Not only can we control the viewpoint used to render this model, but we can also introduce arbitrary virtual objects to the scene. Here, a virtual shiny metallic sphere is added to the scene and moved along a predefined path. As can be seen, occlusions are handled correctly, and realistic shadows and reflections can be calculated and rendered. We can also add artificial diffuse and specular lighting to the scene in real time. Virtual objects can interact with the dense model in lifelike physics-based scenarios. If we drop hundreds of virtual balls into the scene from above, they mostly end up on the floor, but a couple land in the cup. Now that we have this model, we can superimpose the live RGB stream with virtual objects. As these examples show, we get geometrically accurate occlusion handling, even in relatively cluttered scenes, and we also model collisions. Objects moving in the scene, even relatively large ones such as hands and arms, do not impact the tracking too adversely. In fact, such movements can be used to detect touch interactions with objects in the scene. Here we demonstrate this property with a simple augmented reality 3D paint application. When the Kinect camera viewpoint is altered, the accurate registration of the paint with the scene is clearly apparent. In another interesting scenario, the system can be used with a fixed Kinect camera and a moving object. Here, a model of a human torso is being 3D scanned. Notice that the hands and arms which are used to manipulate the object are integrated out as they move around, and no augmentation of the user or the object is required. This results in a detailed CAD model of the object. Objects which move in and out of a scene can be readily segmented by querying the dense model for changes. Once segmented, the object can be tracked independently using the same technique that's used to track a moving camera. We demonstrate tracking here by re-registering the segmented object with a real-world object.
Perfect, and that's the video. It brings back memories, hopefully for other people. I saw Dustin's comment around the presence of the torso in that room. Just to give people context, there was a secret room in Microsoft Research where a lot of the team was sitting and coding day in, day out, including myself and Richard and Dustin and all the folks that were working full-time at MSR. So it was a pretty intense time for about 6 months. No one slept leading up to various paper deadlines. So it was definitely an interesting time, an exciting time, and that video definitely brings back memories. As you can see, we modified the video for the final submission as well. Added sort of additional demos and improved the system somewhat as well. Great.
So
yeah, Richard was mentioning, we also scanned Sir Isaac Newton's death mask using the system as well. There was a few sort of moments with KinectFusion. I remember another one where Bill Gates gave a demo at University of Washington. Richard, that will always remain with me. That was an incredible moment. So great, and I think Otmar's sharing the video link as well with the audience. And Wendy, over to you, and we can answer any questions that you might have, and also turn it over to the audience.
Yes, great. Well, thank you very much. I remember seeing this, and this is one, we talk about the wow factor at UIST, but this one really, really had the wow factor. Everybody in the audience was like, whoa. And it was just a very, very impressive, because I think it's this idea that there's a Kinect, but then there's all these things you can do it, and you could project yourself into it and see how this could be incredibly useful. And so there's a series of questions that we've talked about asking, and I'm going to just ask you one thing about what was the inspiration for this? You said that the idea was to move from a fixed Kinect on top of the TV to something that you move around. How did you get that idea, and why did that? How did that inspire everything else? Because I think that's the key shift, is a flip in how we think about these cameras.
Yeah, that's a great question, Wendy. And let me just very quickly and briefly answer it, and then I'll turn it over to Richard and others to give their points of view as well. From our perspective, we had a project at the time that was trying to do full 3D reconstruction of a room, including capturing people with multiple Kinect cameras. And the aim there was to augment your space with augmented reality capabilities. So at that point, there wasn't a HoloLens device or augmented reality device that was high enough quality. So we were looking at projection mapping technologies and various other technologies, actually collaborating and being inspired from Andy Wilson and Benko and others as well at MSR Redmond at the time. And the aim there was to basically build a system where you can walk into a room and every atom, every physical object is reconstructed and tracked. One of my goals personally, and I think everyone has a different story to tell here, so it's good to hear everyone's perspective, because I think that was one of the things that's really compelling about KinectFusion. People were coming at this project from very different angles. One of my own personal goals was to build this 3D capture system, this room that was instrumented in a lightweight manner, but you can basically reconstruct everyone in that space, including the physical space itself, such that we could use it for telepresence. And sort of, if you look at the lineage of work that happened after KinectFusion, both from our team, but also externally as well, a lot of inspiration came from external teams, actually including Richard and others with some follow-up work, for example, Dynamic Fusion. We were essentially building on top of this research to solve this problem of 3D reconstruction, reconstructing a space to then use in telepresence. And that's what became the holoportation project sort of 6 years later in Microsoft research as well. So we kind of had to solve many problems along the way, and we were probably a little ambitious for the time in 2010. But even back then, the seeds for holoportation were born, and this idea of basically lightweight instrumentation of a space so that you can communicate with someone else that's remote from you in as physically a plausible way as possible. So that was one of the sort of inspirations for the project. But as I mentioned, everyone had different perspectives coming into KinectFusion, and that's what made the project special. So I wanted to pass it on to Richard for some additional insights.
Thanks, Shahram. Yeah, and definitely exactly as Shahram says, there's these different perspectives that came together. Historically, of course, the Kinect was this set-top box on top of a shelf system, and it even had a motor in, designed for getting your avatar or controller, you are the controller, connect, and that obviously was the paradigm which was influential at the time. At the same time, in a universe not that far away, the paradigm of robotics and otherwise mobile AR was sort of like burgeoning this or requiring that you pick up the camera and move around, because you cannot have infrastructure everywhere you go unless you take that infrastructure with you. And of course, a robot takes its sensors and takes its compute, and actually, as we now understand, AR glasses take their sensors and compute with them, and so suddenly the infrastructure is mobile, and that requires to solve this fundamental thing that otherwise is like a part of building an infrastructured capture system, which is what is called the calibration of the cameras and where they are in space and time. And in robotics, that's being called SLAM, or solving the simultaneous localization and mapping problem, because the map in this case means some sense of what the environment looks like, so that you can reference essentially this camera, because you don't have a calibration grid everywhere, so you have to build your own calibration grid. So this whole paradigm of take the infrastructure with you is really the one that says, well, let's pick that Kinect camera up, and the rest is kind of history in that respect. The other sort of connected paradigm, though, to exactly Shahram's view that had brought this concept of holoportation and building a holodeck, whether it was with infrastructure or people have brought their infrastructure with them, is the idea of digitizing reality. And that actually is the foundation on top of which, whether you're from robotics, augmented mixed reality, user interaction, if you've got a model of yourself, if you've got a robot model and a model of the robot, so these are always sort of equivalent. If you've got a model of yourself, you've got a model of your environment, if you've got a model of how these things can interact, then you can start to augment that digital reality and overlay actual reality with augmentations or information. You can start to cache information in that model of reality and relocate it afterwards efficiently and so on. And that's the paradigm shift. It's essentially capturing reality at a level of fidelity that really says, you can reference that model as if it were reality. I can render from that model given a camera pose, and it will look like reality. And suddenly it's like, well, that's teleportation then. So if I've built a model of reality in real time, kept it up to date, and I can transmit that, compress it, transmit it, decode it, render it at the other end, then that is holoportation. So that's also, though, how you actually get interaction between the human and the surface, as was demonstrated in the video. And it's also how robots can do planning on, you know, the model without having to test out interaction. And that opens the door to a lot of things like reinforcement learning paradigms on the model of reality without having to do the actions in reality. So whether it was in robotics, augmented reality, or user interaction on top of those paradigms, human computer, human robot interaction, the foundation is a digital copy of reality that is kept up to date. And ultimately, you've got to take your infrastructure, your sensors with you, or put cameras everywhere. And we were certainly saying, well, what if one day there were mobile versions of Kinects? And we know now that's happened, of course. You know, there are phones you can buy, and they have these tiny depth cameras in them. And of course, as Dave Molyneaux pointed out, the ML1 from Magic Leap had a version of KinectFusion running with a mobile depth camera on the system, and of course HoloLens the same. So within a very short period of time, that reality became real. Back to you, Wendy. Yeah.
Well, I'm actually going to, I'm very delighted that Celine has asked actually 2 questions, and one of which was one I was going to ask myself, so great question. There's a question of what is your favorite follow-on project? So you've talked about a variety of different applications, and this is to everybody, but what do you think is the most interesting one that has sort of been really cool from your point of view? And there's a secondary question in there that I'm going to stick in quickly because I think it's really nice. Are there any interesting applications of this that you've seen by artists or performers? Because that's usually a very creative space for exploration. So that's 2 questions, not one, but Richard, feel free to ask, or anybody else pitch in.
I'll kick us off with a really short one and then pass over to you, because at the same time as these depth cameras coming out, there was the creation, or if you like, the commoditization, as KinectFusion commoditized 3D reconstruction. These 3D printers came out and allowed you to start to sort of like recreate these physical copies of reality. And at the time, certainly it wasn't something I was thinking about, but for at least like a good part of the people I interacted with, they were enthusiastic about the potential of copying artifacts and actually, you know, creating busts of friends, families, and so on, or literally copying things. And of course, you know, we don't have fully functional 3D printers. They're still pretty much just the surface, and KinectFusion only gets at the surface, so it's not like you can copy functional objects. But the potential of sort of like that end-to-end capture was certainly something that isn't in sort of the paradigm of robotics or augmented reality as such. It's like in this physical capture paradigm, and sort of the commoditization of 3D printing was one that went very naturally. And we saw a whole rush of sort of like companies actually starting up and using the simple algorithms in KinectFusion to go and do that. So that there's several others I can talk about that were inspiring, but that was certainly one that I didn't anticipate. And it was exciting to see that in several sort of like friends, family, and colleagues sort of have got mini busts of their children scanned in with KinectFusion and printed out, which I think is really fascinating.
I mean, just to follow up on that, when watching that video, which I think many of us haven't seen for 10 years now, and there's this huge torso that's part of it. And I have a very strong memory of that torso, but my memory, it's this tall, because in parallel, just like Richard said, in parallel with thinking about scanning, we had this project which was atoms to bits, right? Like, can we get a digital representation of the world? We also had another strand of work called bits to atoms, and we were interested in recreation. And so we actually, we took that scan and we had a whole bunch 3D printed, and you couldn't print it like full size. So we've got all these little miniatures around, which is what I remember of that. So it's kind of, resonates with what Richard just said, resonates with me. But I also wonder if we could, if Shahram or maybe others would like to talk a little bit about holoportation, because in some ways that was what I saw. I wasn't involved in that project, but for me that was a very natural progression from KinectFusion. With KinectFusion, like again, Shahram said, we were sort of trying to think about this telepresence, and KinectFusion was sort of beginning to give you. You could see the beginnings of how you could recreate a scene remotely, but I think what Shahram and others did with a holoportation project was a really exciting follow-on from my perspective.
Steve, that was really nicely put, the sort of concept of atoms to bits and then bits to atoms. I remember those two being sort of big themes for the research group at the time. And I think Richard connected that, you know, once you have those two capabilities and a network in between, you have the holoportation system. So I do think there was this kind of natural evolution of the research to sort of get closer and closer into that telepresence teleportation scenario. I think just going back to Celine's question, favorite follow-on project, that was probably the most compelling thing for me about this project, is just seeing the wealth of follow-up projects that we saw from all different angles. So from, as Richard alluded to, from robotics and the sort of SLAM community, all the way to HCI communities, augmented reality, and even artists and performers adopting the Kinect camera as well, Celine. For example, I recall Chris Bregler at the time did some incredible work capturing ballet performances using multiple Kinect cameras. He was also using Vicon tracking at some point as well. I remember Audrey Penvan used the Kinect and actually used the dot pattern from the Kinect to do performance art. Those were sort of two things that remain in my memory. Celine, you probably remember other work that had happened. Maybe actually you actually did some performances as well using the Kinect. Is that right?
I don't know if Celine is still there, but I can say that we did a sort of an interactive Santa Claus, and with a mechanical Santa making factory at in a shopping mall as a Christmas display, and little kids could come up and dance in front of Santa, and not just, and the Kinect is following what the Santa Claus is doing, but also then shifting around and starting to react in different ways so that the kid starts to learn what the Santa will do to make the whole mechanical factory go. It's much easier to talk about in a video. But anyway, there were we were working with people who did the theater presentations, and they built this amazing set and had all of this stuff. And we couldn't have done it without that kind of technology. And it was very inspiring. We're running low on time because, of course, there's lots of things to ask, but there is an interesting question here, which is, how do we think about the mobile technology? So we have AR, mobile AR, and so on, but the question from Michael is that it seems more, that KinectFusion seems more powerful than what we have right now. Is that your impression, or is that something that's just coming, or where are we with that?
Yeah, I think that's a great question. The mobile AR world is changing rapidly. Obviously, we see new types of depth cameras that are available on mobile devices, like the iPhone and iPad now has this LiDAR system that can generate very high quality depth maps. In AR Core, we actually use KinectFusion under the hood, as well as many different other system components to build depth map capabilities just from the RGB camera. But obviously with just a regular color camera, you can't get as much information in certain places if there's textureless regions, etc. But I do think that technology space is one that's rapidly shifting and changing, and people are pushing for real-time digitization using headsets and glasses and mobile phones. So we are going to see a lot of technologies emerging in those spaces. Definitely want to hear back from others who haven't had a chance to speak. Andrew, you were just chiming in there.
text is adequate, but yeah, no, just this point that because it was available on a consumer device, you could download the code and just run it. We were used to, as academics, publishing a paper, and then suddenly, 1,500 people would want to be able to use your thing on their thing, and you could pick one or two if you were lucky to collaborate with. Whereas because KinectFusion was just available and re-implementations were just available, I think that was crucial to it permeating a lot of areas that we didn't even realize until way later.
And I think that's a really important point. One of the questions that we often struggle with is, what is the impact of what we do as researchers in the rest of the world? And this is a wonderful example of something that is a collaboration between research and industry and academic researchers coming together, really focusing on a really innovative, groundbreaking way of thinking about a research problem, and then putting it out to the world in a way that other people can adopt it, and then have that inspire companies and other researchers and other people. And of course, that's why you have so many incredibly large number of citations. But those are academic citations. You also have a huge impact in terms of startups and different things that are in different companies. And if we look at the careers that you've all had, you've all gone on in different ways and spread out in different places and spread this way of thinking. I'm afraid that we are out of time at this point. It was really a pleasure to get to see you all. I hope you enjoyed meeting each other again. And I really think this was, as I say, probably the easiest one to give in terms of a Lasting Impact Award for UIST, because it's just had an enormous impact. And I want to congratulate you all again and thank you for participating. We put this together very, very rapidly, and you're all spread out all over the place. And so thank you to everybody for coming together, and thank you to the audience for being here and having a chance to listen and think about these new, still inspiring technology. Thanks, everybody.
Thank you. Great seeing everyone.
Farewell.
Yeah.
I'll see you.
Thanks, everyone.